Many of you guys know that I've run Autodesk Labs for the past several years, and we've brought dozens of new technologies to market. Many of those technologies have involved reality capture, and our customers have been very passionate about these reality capture technologies and how it's helping them improve their processes. So I've left Labs to go grow a new organization that's wholly focused on the reality capture process. Now, if you haven't heard me talk before at Autodesk University, for example, then you probably don't know what I'm talking about. So first, let's back up. CAD tools today, or design tools, are incredibly powerful. They can help us experience very complex ideas before they're real. And they can coordinate the activities of huge crowds of people to turn those ideas into a manufactured or built world. But all of these very powerful tools have one simple shared problem, and that's that they start as a white sheet of paper. Now, in order to create a vision of a new future, you have to measure and model that reality before you can get the CAD benefit. Now, reality is complicated. It's very complicated. And even if you have the simplest to use consumer-oriented design tool, you must first measure and then model that world before you can use it. And this is a huge barrier to entry to using design. And so we want to reduce that. Now, about a decade ago, this invention really started to change things. The laser scanner could take millions of points, accurate 3D positions, in the same amount of time it used to take just one through manual methods. But these devices were hard to use and very expensive. And over the last couple of years, we've seen the price drop dramatically. And that, of course, is raising the adoption of these devices. So in the last couple of years, you've seen us start to incorporate 3D point cloud technology into several of our products, bringing that laser data right into the vector-based CAD world. If you take this forward, though, you start wanting to not just work with dumb 3D points. What you really want is that CAD model. And so some of our research that you've seen come out of labs and that's being incorporated into products is the ability to extract information, classify data, civil objects, being able to extract pipes in a factory, or in this case, scan directly into a BIM model. And that, again, is going to lower that barrier to using design because the real value is in the design, not in the modeling. And yet, most of our customers today spend inordinate amounts of time doing design. The other trend that we're seeing happen as these devices become more ubiquitous by the professionals is that the data that was once captured in a scan at the beginning of the project and at the end of the project is now happening on a daily basis. So daily scans are resulting in massive quantities of data. And so in order to accelerate our ability to handle that data and work with point clouds, we recently acquired Alice Labs. They have technology that not only allows us to work with massive models, but also not work with ghostly, hollow points in space. We can now have point surfaces instead of point clouds. We can visualize things as we expect them to be. Each tag in this video here is a separate laser scan, and you're seeing that we can work with billions of points interactively. Take that a step further, in the near future, we'll be able to do several modeling type operations directly in the point cloud without any need to go to vectors, as you could see here. One other advancement that we see, because this data is exploding to the point where the data set sizes are growing faster than laptop hard drives, is that we're going to need to move the data to the cloud. It's the only way to access that much data when we can't store it locally. And that'll allow us to share it as well. Now, there's a new technology that I can demonstrate to you on the break where on an iPad, we're literally streaming billions of points from the cloud to mobile devices where it can be accessed by anyone, anywhere. But reality capture is more than just three-dimensional positions in space. Reality capture is capturing all aspects of reality, or multi-channel reality. As an example of that, this is a material scanner. It looks at how a material property like wood reflects light from all different frequencies and all different angles. And it can generate about a terabyte of data per square centimeter. That's how you can get visualizations that are like this. Being able to accurately measure the actual light reflectance of materials is what allows us to have the pictures in the IKEA catalog indistinguishable from reality. But that's just one type of multi-channel data. There's many types. We can collect weather data, pressure data, temperature, occupancy, you name it, ground-penetrating radar. We're seeing more and more ability to take the analog world and digitize it. And at the heart of it, think of what building information modeling or digital prototyping are really about. They're about a model that relates many different types of data together so that we can do simulation, planning, and true design. And so as we reduce these barriers to capturing reality, we allow ourselves to get richer and richer models that are more accurate in their simulations and play more what-ifs. We get better design as a result of reality capture. But more importantly, we change who gets to participate because we make it that much easier. So a great example of this is Project Dasher. This is a project that we have going on internally where we took one of our office buildings in Toronto, we laser scanned the heck out of it, and we made a very accurate digital model. But we didn't just capture reality in 3D. We put sensors in every single cubicle and every single outlet, measuring the electricity usage, occupancy, temperature, light that's coming in from the windows, motion, you name it. We've got sensors all over. We put that into a massive building information model. We can hook into the mechanicals of the building as well. And what this allows us to do is make a more sustainable building. We can do better sustainability design on a building. Really, this is something you just couldn't have done before. It's a live BIM model that allows us to see how the occupants change the operation of the building. We've seen many times with LEED buildings that they don't perform as designed, mainly because the occupants don't behave as expected. And so with real-time capture and historical data, we can bring that now into simulations with Project Dasher. Take that to the next step and look at some other ways that we can incorporate this into the infrastructure or the manufacturing world. This chip here uses parasitic approaches to generating its own electricity from vibration. To it, you can connect an array of sensors, analog sensors that convert into digital. It has a wireless capability to transmit packets of data to a central location. You can pour this into concrete, into a bridge, or into a foundation of a building, or glue it to a machine. But that's really about what professionals are doing with reality capture. Really, the thing that's exciting me a lot is how we're bringing this technology down to everyone, and how the compute power of the cloud is leveling the playing field. Last year, we introduced 123D Catch. This was technology that using any ordinary digital camera, a $100 camera, anything that you have in your pocket, throw those pictures up to the cloud, do a bunch of compute there, and the result is a very accurate, detailed 3D model. That is not a video of a shoe. That is a model of a shoe. And you can see there's about 750,000 points in that model, all from a consumer digital camera. Now, when we developed that technology, we were expecting it to be used by professionals for rapid energy modeling, for making more sustainable buildings. We talked to Amory Lovins when he was retrofitting the Empire State Building, and he said it took him 9 months to get the as-built condition of that building before he could do his first simulation. And so we thought people would take a bunch of photos and rapidly make energy models, and that's just what's happened. DuPont, for example, has used 123D Catch to bring their building into Green Building Studio for analysis. What we didn't expect were all these other uses of the technology, and it's really started to blow our minds. This just came in a few days ago. The Scripps Institute, NOAA, and several other research organizations have been studying our coral reefs and the disintegration of those coral reefs. One of the ways that they're studying this is by taking tape measures of these grids, trying to map them out, make three-dimensional models, and then come back a year later and see how that coral has changed its volume, its shape. It's not just linear measurement, it's 3D that matters. And this is the process that they're using. In an afternoon, one of our engineers here, Pete Kelsey, took 16 photographs, and in 10 minutes, we had 500,000 3D points using 123D Catch. It blew their mind. There's now all sorts of research going on in this area about how to really study very accurately what's happening with the coral reefs. But we've also seen this technology, this reality capture, come into the entertainment industry. You've seen it in the movies, avatars, and things like that. But people are using Catch, for example, in music videos to get an artistic effect and combine it with augmented reality. Our good friends over in Oakland, SciArc, they are a nonprofit that is trying to do historical preservation. They're using laser scanners to capture the UN World Heritage Sites. And over the last 5 years, they've captured roughly 50 sites very accurately and preserved them for all time. But it's a very slow process carrying lasers around on airplanes. So what we're doing is starting a new project to crowdsource volunteer photographers in different cities. And our first project is to photograph the California missions. One of the neat things that you can do for historic preservation is take something that no longer exists. A decade ago, the Taliban blew up the Bamyan Buddhas in Afghanistan, and we've brought them back using catch technology from historical photographs. Another use case for this is in education. We met Louise Leakey a year ago and started working with her. She has 20,000 fossils in Africa, many of which are locked up. The government requires all sorts of permits in order to even open the vault because some of these artifacts are so rare and so special. And so how do you bring that out to researchers or students? Well, over the last year, she's been taking a whole bunch of photographs of these objects and turning them into 3D models and created a website, africanfossils.org, which can be used in education. A student can click on one of these fossils, turn it around in 3 dimensions, and explore things like how the cranial ridge evolved over time. So that's great for consumerizing or democratizing reality capture. And laser, as we know, is today for the professional. And this has been a conversation in the reality capture market of, photo versus laser. Our strategy is really about taking these two technologies that we have and combining them. And in the future, you're going to see laser and photo. This is a case where 1 and 1 makes 3 as to what you can do. So stay tuned with that. But one of the concerns that many people have when you bring this together is that, gee, is photo really accurate enough in order to play in this professional space, in order to play with where lasers play today? And this is a comparison of the same building. You're now seeing a cross-section of that building, and we're comparing the reference, which are the blue point clouds, to what we can do today in red with photo-based approaches in catch. And you can see that there is some variation. It's fairly close, though. But coming out of our research, the next generation of this technology is what's in yellow. That's photos compared to the blue lasers, and it's amazingly close. So when we combine these technologies in the projects of the future, we're very excited about that. Now, let's take that to the next step. There's another innovation that's been happening that you may have been following, and that are drones. Drones, started in the military, much like the internet, and they're having a profound effect. This drone is a next-generation drone from the ones that you may have seen. This is an autonomous drone. It flies itself for 20 minutes at a time with no human intervention. And what's beautiful is that it can carry a 6-pound payload. That payload is a whole series of cameras, high-resolution cameras that can go out and digitize reality. So a week ago, we drove up to Napa, and this is a winery in Napa, and we took our drone and we created this 123D catch model from drone photography. And here's a sample of some of the photography that drone, this drone right here, was taking last week. So now, imagine combining that with this technology that we already have. This is our infrastructure modeler product. It lets us do city-scale modeling in detail. And the biggest barrier to using things like this, of course, is where do I get a digital city from? But when you combine laser, photo, and drones, and all of these different reality capture methods, we are going to have city-scale models delivered from the cloud. Now, an artistic visualization that Parsons Brinckerhoff did here is this. Instead of calling this building information models, my good friend Doug, he calls this BAM, or big-ass model. And that's really what I think reality capture is going to do for us with the cloud. Well, let's shift gears here. We really want to democratize this technology even further. And it isn't just about the building or infrastructure industries. It's also about manufacturing. Now, if you think of the music industry, the ability to capture analog data into an MP3 file changed everything. It was the MP3 file that allowed for iTunes all the way to Spotify today. And that same thing is going to happen in the manufacturing space, and it's going to be enabled by RIP. For example, we're seeing these personal fabrication machines, these 3D printers that can print any shape, just any digital 3D shape. And so the next problem is, how do we capture that reality? Nike, in fact, they had shared this with us several years ago, and they just released this a couple weeks ago. This is their new Flyknit shoe. This is a shoe that is not made from a mold. It is knit by a machine in 3 dimensions. It's basically a shoe defined by software rather than by a mold. And when a shoe's shape is defined in software, it means that no two of them need be the same. And if no two of them are the same, the question is, how do I have personal manufacturing? It's going to be a dramatic change to the way we get our products, personalized all the time. And the key to unlocking this personal manufacturing industry is RIP, just as it was with the MP3 file to the music industry. So some of the research that we've been doing is taking other reality capture devices that RIP, such as the Kinect, the most successful consumer product in history. Here we have a Kinect and a researcher who's using it to paint their environment in 3D and capture very easily. They can get immediate feedback to any occlusions or spots that they've missed. But how do we make it even more ubiquitous? You don't have a Kinect with you wherever you go, but you do have a mobile device. And so what we've introduced is 123D Catch Mobile. Whoops. No, cut back to the video there for a second. Somebody's been using my iPad here on the break. So I'm going to have to bring it back. There we go. So this is 123D Catch Mobile, which allows you on any mobile device to take pictures, generate a 3D model, work with a community and share your designs, customize it, and then get it made through various rapid prototyping machines and providers. Okay, and so what I have here is an example, and it keeps cutting out, of this new Catch Mobile simulation. So this is an object that was captured directly from the iPad, and I can go in and simulate it. I can connect it to a community of people and get these things manufactured or customized. Okay? So I think in summary, Chris Anderson from Wired Magazine said it best, and that is that atoms are the new bits. That's really what RIP Mod Fab really means. And so to show you how we're going to democratize reality capture and not just use it in isolation, but take reality capture to design and design for all, I would like to introduce to you Eric Wilhelm, who is the head of Instructables. Thank you.